If you like this video, be sure to subscribe and hit the bell icon. Share it with a friend and I'll be doing more videos like this just for you.
Science 10 Module 4. Why do tectonic plates move?
Hi grade 10 students! Congratulations! You are now in Module 4. In Module 1, we learned that the geological features and activities such as earthquakes, volcanoes, and mountain belts are related to the location of tectonic plates.
In the second module, we identify the types of boundaries that exist between these plates and we describe how they behave and interact. The third module explored the different processes that the plate boundaries undergo and the geological formation and activities that they cause. All in all, we already learned a lot. Let us give ourselves a round of applause. However, there is still a lingering question. Why do the tectonic plates move? Well, hang tight as we journey towards answering this question.
The tectonic plates of the Earth's lithosphere move at an average of 2 to 20 cm per year. The individual movements of these plates create different types of boundaries and consequently different geological features and activities.
Finding out the explanation for these movements took a lot of effort from scientists. Different theories and concepts were put forward until the accepted scientific consensus evolved into the current theory we have today. This module is based on DepEd's most essential learning competency or the MELC number 4 for Science 10 Quarter 1. Our learning competency is describe the possible causes of plate movement. At the end of this module, you are expected to accomplish the following specific learning objectives unpacked from the competency. 1. Enumerate the various theories, concepts, and scientists that contributed to the current scientific explanation of why the tectonic plates move. 2. Describe the concepts put forward by each theory or concept. 3. Trace how the theories and concepts evolved into the theory of plate tectonics. And number 4, explain how plate tectonic theory explains the possible causes of the plate movement. To make sure we are in the same page, let us review some concepts from the previous modules. Refer to the map and answer the following review questions.
Science is often trial and error. We can have our current understanding of plate tectonics today because of previous theories and ideas put forward by several scientists. Let us find out what these are. Theories and concepts unrelated to plate tectonic movement. Continental drift theory. In 1912, Alfred Wegener, a German meteorologist, proposed a theory that about 250 million years ago, the continents were once one large landmass. He called this landmass Pangaea, a Greek word which means all earth. He thought Pangaea started to break into two smaller supercontinents called Laurasia and Gondwanaland during the Jurassic period. The smaller supercontinents broke into the continents and these continents separated and drifted apart since then. Evidence-wise, the theory of continental drift was very sound. Wegener was able to present various lines of evidences to support his claim. These evidences will be discussed in the next module. However, scientists during his time did not accept his theory because of one glaring flaw. It provided no mechanism or means of how the continental mass moved. The theory was thought to be incomplete. Seafloor spreading theory. Seafloor spreading theory addressed the one weaknesses of continental drift theory. It offered an explanation to why the continents move. The invention of sonars and submersibles in the 1950s and 1960s enabled scientists to make better observation and gather new information about the ocean floor. They have discovered a system of ridges or mountains in the seafloor. These are called the mid-ocean ridges. After conducting observations and gathering multitudes of data, scientist Harry Hess, together with Robert Dietz, suggested an explanation to the continental drift. This is the seafloor spreading theory. According to this theory, hot, less dense material from below the Earth's crust rises towards the surface of the mid-ocean ridge. The material flows sideways, carrying the seafloor away from the ridge and creates a crack in the crust. The magma flows out of the crack, cools down, and becomes the new seafloor. Over time, the new oceanic crust pushed the old oceanic crust far from the ridge. This movement of the oceanic floor is a mechanism that caused the continents to drift. Although the seafloor spreading theory can explain the movement of continents, it contradicts a part of the continental drift theory. According to the previous theory, continents move through unmoving oceans and that larger, sturdier continents broke through the ocean crust, whereas the seafloor spreading shows that the ocean is the actual site of tectonic activity. Convection currents in the mantle. The question of how the continents drifted was answered by the seafloor spreading theory. Continents were being pushed by the gradual spreading of the seafloor. However, another question arose. Why does magma rise from the mantle out of the ocean ridges to start the process of seafloor spreading in the first place? The answer lies in the basic concept of heat transfer, which you have learned in grade 7. This concept is called convection. Recall that convection is defined as the movement caused within a fluid by a tendency of hotter and therefore less dense material to rise and colder, denser material to sink under the influence of gravity, which consequently result in transfer of heat. Various excavations and experimental drillings have taught us that the temperature of the Earth's material becomes hotter as we go deeper. It is therefore a known fact that temperatures in the deeper mantle are much higher than in the asthenosphere, a mantle layer just below the lithosphere. Just as when hot air rises and cool air sinks, molten materials in the mantle also behave similarly. Hotter magma from the deeper parts of the mantle rise up and cools down in the process, while magma from the asthenosphere, which has cooled down, sink to the bottom. The magma that reached the bottom is again heated and the cycle repeats. This results in the formation of circular flow of molten materials we call a convection current. The upwelling of this convection is what breaks the seafloor to form an ocean ridge and start the process of seafloor spreading. Internal structure of the Earth. Convection currents are formed by temperature differences in the mantle and the layers below it. But how do we know for sure that it is a fact? Scientists are confident that this is the case because they have studied the internal structure of the Earth thoroughly. Using data from earthquakes that propagate internally through the Earth, they have determined its layer, their phases, and boundaries. Based on composition, the Earth is made of 3 layers: crust, mantle, and core. But based on mechanical properties and behavior, the crust and the upper rigid solid rock part of the mantle form the lithosphere. Just below this layer is a partially molten fluid-like layer called the asthenosphere. This configuration allows convection currents to form especially in the fluid-like asthenosphere layer. Also, the presence of the mechanical layer called lithosphere means that continents and oceans do not move on their own. A whole lithospheric plate or segment moves carrying the continents and seafloor. The composition and temperature of each layer is determined from the combination of direct observation, earthquake waves data, chemical analysis of material coming out from volcanoes and ridges, composition analysis of asteroids said to be the building blocks of planets, mathematical calculation from fluid dynamics and material science, computer simulation of early solar system, planet formation, and mathematical reconciliation of the density of the Earth to its orbital behavior around the Sun as dictated by the gravitational laws. Looking at the temperature of the Earth's layer, we can see the core is the hottest. This supports the concept of convection current formation. The core serves as the source that heats up material at the bottom of the mantle layer, kick-starting the circular motion of molten rock and magma. The mantle, especially the asthenosphere, acts like the heated fluid. The lithosphere floating on top of the asthenosphere is affected by any movement in the fluid. Movement of lithospheric plates. When a lithospheric plate splits into two by forming an ocean ridge, the segments move apart. As this motion continues, they are bound to collide with neighboring plates, forming subduction zones where one of the colliding planes sink under the other, as explained by modules 2 and 3. One of the factors for the motion of the lithospheric plate is ridge push. This refers to the force of rising magma as it punches through the oceanic ridge. Another factor for the motion of the lithospheric plates is mantle drag. This refers to the sideward force exerted by the moving convection current underneath the lithosphere. The last factor for the motion of the lithospheric plate is slab pull, the downward force due to the weight of the subducting slab. Plate tectonic theory, how we got there. Today, the unifying theory of geology is the theory of plate tectonics. Tectonics comes from the Latin word tecton, which means builder or carpenter. Indeed, the process that plate tectonic describes are able to explain how the features of the earth, such as mountains, volcanoes, trenches, etc., are formed.
As discussed in the previous activities, this theory was built on top of another theories and concept that came before it. In this activity, we will try to reconstruct the plate tectonic theory from the mentioned concepts. Below are statements from the previous theories and concepts before the plate tectonic theory was formed. If we eliminate the ones that were proven wrong and retain only the ones that are proven correct, we should be able to form the current version of the theory of plate tectonics. For this task, below are a pair of opposing statements from different theories or concepts. Evaluate each statement. Write a check mark on each box if the concept is considered the more correct statement. Write an X if it is the less correct one of the two.
Plate tectonics theory tells us that number 1, the seafloor also drifts and moves just like the continents. 2, movements of the lithospheric plate is the reason why continents move. 3. The upward direction of convection current causes magma to rise out of mid-ocean ridges. 4. Continents or continental crust and oceans or oceanic crust are part of the lithosphere, and so when the lithosphere moves, so do the oceans and continents. Okay, tectonic theory tells us also that 5. Magma coming out from mid-ocean ridges push segments of the lithosphere to the sides. 6. Lithospheric plates move. Continents are part of the lithospheric plates. 7. The core heats up materials in the mantle, making them rise, initiating the formation of convection currents. 8. Convection currents are possible in the mantle because molten magma, especially in the asthenosphere, is fluid-like. The statements on the next slide are concepts postulated to be true by the plate tectonic theory. As was discussed from the previous slides, the concept of this theory evolved from continental drift, seafloor spreading, convection currents, and internal structure of the Earth. To find out if you understood what these concepts are and how they evolved, read the statements and identify the origin of the concept. You can write multiple answers to each number if it applies. The following options are continental drift theory, convection current, seafloor spreading theory, internal structure of the Earth, and plate tectonic theory. Debunking local myths about earthquakes. A popular myth in our country is about Bernardo Carpio. He is said to be a strong giant who trapped between two mountains. It is said that when he moves his shoulder, he shakes the mountain and creates earthquakes. Another myth explaining the occurrence of earthquakes originates in the Visayas area. According to old local folk, there is a giant wild boar that roams underneath the ground, causing it to shake. Whenever an earthquake occurs, you must therefore drive the boar away by saying "Bua! Bua!" loudly.
Now that you know the correct scientific explanation for the movement of tectonic plates, how would you explain to the advocates of these myths the correct scientific concepts? Your next task is to make a creative presentation expounding on the correct explanation on why earthquake occurs based on the movement of lithospheric plates. Focus on why the scientific explanation makes more sense than these myths. The presentation must be convincing but still respectful to the myths that are part of our cultural identity. In your task, the output could be a comic strip, an explainer video, a creative drawing, a poem, song, a rap, or any creative expression that is able to explain the concept. Refer to the rubrics below for the criteria for scoring. In these slides, it shows the criteria on how your presentations will be graded. Don't forget to submit your output to the agreed platform that we have.
Thanks for watching. Don't forget to like, and if you're new in this channel, click subscribe to be notified with more videos like this. See you on my next video. Goodbye!